Hello everyone, thank you for checking out this video. You are with Coach Deathbot from 32 Academy. To start off, we start with question 1. The question asks to find the value of this expression. So you have two fractions adding together. The first fraction is log base 5 of 9 multiplied by log base 7 of 5 multiplied by log base 3 of 7 over the denominator is log base 2 of square root 6 plus the second fraction is 1 over log base 9 of square root of 6. So what is the simplified value of this expression? Okay, let's try the question together. So from here, notice that I can change this expression to become log base 5 of 9. I can change it to log base 5 of 3 multiplied by 2, right? Because basically that thing will equal to 2 log base 5 of 3, because 9 is equal to 3 square, and then with the property of logarithm, the power 2 can drop to as a product, scalar product, and then the rest do not change. Okay, the rest I just copy down again, divided by the same denominator, and of course the last one, the last fraction also do not change. Okay, so how to continue from here? And now I start to change the base, right? So log base 5 of 3, I can change it to log base 10 of 3 divided by log base 10 of 5. Again, this is just another property of logarithm. Same thing, log base 10 of 5 over log base 10 of 7, log base 10 of 7 over log base 10 of 3, divided by the denominator, do not change anything, plus 1 over log 9 root 6, do not change anything. Okay, let me write this a little bit lower, is equal to 2 multiplied that. The reason, you notice now, like the reason why I do this, so I can cancel out, right? Log 5 can cancel out, log 7 can cancel out, log 3 can cancel out. So technically this would just be 2 multiplied by 1 over log base 2 of root 6. Okay, plus this 1 over logarithm, I can change it to log of, you reverse the base and the number in front, right? So become root 6 to become the base of 2. I can do the same thing for the second fraction. Log root 6 become the base of 9. Okay, so now you notice that both logarithms have base of square root 6. I can combine it to become just one log function. These two, first thing first, come put as a power. Alright, so it becomes 2 square. Sum of log is log of product, so multiplied it by 9. Okay, so let me write in front since I do not have much space. 2 square is 4. 4 times 9 is 36. 36 you can write as square root of 6 to the power of 4. And as you can see here, that is just equal to 4. Right, so the simplified or the final value of this complicated expression at the end is just equal to 4. Moving on to question 2. Let's read the question together. Given that tangent of angle A is 12 over 5, cosine B is equal to negative 3 over 5, and that angle A and angle B are in the same quadrant, what is the value of cosine angle A minus angle B? Okay, so let's proceed to solve this trigonometry question together. Okay, notice that tangent A is positive, right? It's 12 over 5. Cosine B is a negative value. And it's also given that A and B are two angles in the same quadrant. In the same quadrant. So what can we infer from this? Angle that has tangent positive can only be in either quadrant 1 or quadrant 3. Okay. For cosine angle to be negative, it needs to be in either quadrant 3 or quadrant 4. Alright. So, sorry, quadrant 2 or quadrant 3. Sorry for that. Okay. And because it is given that A and B need to be in the same quadrant, so we can infer from here that A and B are in third quadrant. Okay, so now we already established that both angles are in third quadrant, meaning we can determine the sine and cosine of each angle. Okay, so sine A, it's not hard to deduce that given the fact that tangent A is equal to 12 over 5, so sine A would be, first thing first, it's in third quadrant, meaning it has a negative value, so negative 12 over 13. And cosine A, being in the third quadrant, cosine it to be also negative, so negative 5 over 13. For angle B, it's in third quadrant, so sine need to be negative, cosine also need to be negative. Alright. Given that the value of cosine B is negative 3 over 5, it's not hard to see that sine B will be 4 over 5. But remember, because it is in the third quadrant, this is a negative value, and this is already given as negative 3 over 5. Why do I need sine and cosine of both angle A and B? Because remember, the question wants you to find the value of cosine A minus B. Cosine of difference of two angles will be equal to cosine A cosine B plus sine A sine B. Right? This is the formula of cosine of the difference of two angles. You know all of each of these four values. Right? Cosine A, we know that is negative 5 over 13. Cosine B is negative 3 over 5 plus sine A multiplied by sine B. Alright, so after some simplification, at the end you will get a value of 63 over 65. So this is the final value for cosine A minus B. Okay, moving on to question 3. Question 3, the question says, find the number of real roots to this equation. So the equation is made complicated because it consists of absolute value. So x multiplied by absolute value of x minus 1 minus 4 multiplied by absolute value of x plus 3 is equal to 0. Okay, so let's try together. One of the ways to solve this kind of question is to find the value of x that makes the expression in the absolute value function to be 0, right? Because this is where it changed the sign. Okay, so of course the value of x that make x minus 1 to be 0, x need to be equal to 1, and the value of x that make x to be 0 is basically just 0. Alright, so you have two important values to consider here, is when x is equal to 0 and x is equal to 1. So you have two values, which means that you should have three intervals to consider. Okay, so the first interval is when x is smaller than 0. So when x is smaller than 0, meaning that I can determine exactly the sign of each of the function within the absolute value. Okay, so when x is smaller than 0, the equation becomes x multiplied by x minus 1 is a negative number, but because it has absolute value, meaning coming out of absolute value, it needs to be minus of whatever inside the absolute value, right? So negative of x minus 1 will become negative x plus 1 minus 4. Again, because x, remember, we are considering in the case whereby x is smaller than 0. So coming out of absolute value is negative x plus 3 is equal to 0. Okay, this is, okay, just to clarify, it absolute value of a is equal to negative a if a is smaller than or equal to 0. Is a if a is already positive. Okay, so we use this kind of fact. So here you can expand, right? Opening the bracket, expand and simplify, you will get a quadratic equation. Right? So after getting the quadratic equation, solve the quadratic equation, you will get the solution as 5 plus minus the root. The discriminant is 37 divided by 2. Okay, so do I accept both values? Think about that. Okay, in fact, remember, we are considering in the case of x smaller than 0, so I need to check whether these roots fall within the range of smaller than 0. Okay, so you notice when it is plus, it's obviously not smaller than 0, so you cannot accept the 5 plus square root 37 over 2. Okay, so only the negative, okay, is basically admissible, right? So since the plus is not smaller than 0, in fact it's greater than or equal to 0, that means that this is the only root here. Okay, is g only root in this case. Alright, so you should do more or less the same thing. Next interval that I consider is in between 0 and 1. Okay, so if x is in between 0 and 1, the equation will become x multiplied by x minus 1 is still a negative value, so coming out of absolute value is still negative x plus 1 minus 4 multiplied by absolute value of x. But now, because the range that we are considering is x is in between 0 and 1, so x is already positive, so coming out of absolute value is still maintained as x. Okay, plus 3 is equal to 0. Again, opening up the bracket is a quadratic equation, so for the two roots you should get negative 3 plus minus square root, the discriminant is 21 over 2. Again, I do not accept both roots yet. I need to check whether it falls into the range that we are considering, which is now is in between 0 and 1. Okay, again, since negative 3, if you take the negative, this one does not fall into the range. Alright, it is in fact smaller than 0, and only the plus is fall in between 0 and 1. So negative 3 plus, this value fall within 0 and 1. Okay, so here is g only root in this case. The last interval that I should consider when x is greater than or equal to 1, or when 1 is smaller than or equal to x. Alright, so the equation will become x multiplied by, now x minus 1 is guaranteed as a non-negative value. Okay, so coming out of the absolute value would be x minus 1. Minus 4 multiplied by x is already positive, right? So coming out of absolute value is still x plus 3. Same thing, quadratic equation. You would get 2 roots, and the 2 root should be 5 plus minus square root 13 over 2. Again, you need to check whether it is really small, it is really greater than 1. Okay, since the negative is not, okay, it's smaller than 1 in fact. So you need to reject this root. So you only accept the plus. Okay, it's the only root in this case. So for the first case you have 1 root, the second case you also have 1 root, and the third case you have 1 root. So hence combining all the cases, and in total there are exactly 3 real roots. Okay. The number asks how many real roots are there, and the answer would be 3. Okay, moving on to question 4. The question asks you to evaluate this expression. So it's 50 multiplied by, in a bracket, cosine 39 degree multiplied by cosine 21 degree plus cosine 129 degree multiplied by cosine 69 degrees. So how to simplify these trigonometry expressions? Okay. So this expression would be equal to 50. The objective of what I'm trying to do here is I want to change all the angle to be within negative 90 to 90. Alright, so it's in basically quadrant 1 or quadrant 4. Okay, so the angle would be with the absolute value is in between 0 and 90 basically. Okay, so the first two expression is already what I want. Okay, so do not change it. About cosine 129, I can change it to cosine negative 51 degree. Alright, and cosine 69 degree, I can change it to sine 180 minus 90 degree minus 69, so that would be 21 degree. Okay, so probably I can clarify here. How do I get here is because I use the fact that cosine alpha is equal to cosine 180 minus alpha. Okay, and how do I get sine 21? Because I use the fact that cosine alpha is equal to sine 90 degree minus alpha. Okay, alright, so moving on, 50 do not change. Like I said, this do not change. Cosine 21, 51 degree. Okay, so negative can move out first probably. Okay, and then cosine, okay, let me write here, since cosine negative 51, first thing first, I can take negative out first. Alright, because cosine negative alpha is negative cosine alpha 51, and cosine 51 degree, I can use this fact. Okay, that will become sine 90 minus 51, that is 39 degree. Okay, so at the end of the day I will get negative sine 39 degree and sine 21 degrees. Okay, is equal to 50 multiplied by, what do you notice here? Cosine A cosine B minus sine A sine B, right? That means it's just cosine A plus B, which is 39 degree plus 21 degree. Okay, so here and just the fact that is equal to sine A cosine B minus sine A sine B. Okay, so 50 cosine, this is basically just 60 degree, and cosine 60 degree is half multiplied by 50. The final answer would be 25. Next, question 5. The question asks you to evaluate this sum. So the sum of fractions, whereby the first fraction is 3 factorial plus 4 factorial divided by 2 times 1 factorial plus 2 factorial. The second fraction is 4 factorial plus 5 factorial divided by 3 multiplied by 2 factorial plus 3 factorial plus dot 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 all the way until the last fraction is 12 factorial plus 13 factorial divided by 11 multiplied by 10 factorial plus 11 factorial. So let's try. First thing first, to solve this kind of sum or product of like certain similar fraction, okay, you need to get the pattern of each fraction first, right? Or the general term. Okay, so here the general term would be, let's start from, if you take this value to be n, okay, this value to be n, this value to be n, so the numerator would be n plus 2 factorial, correct, plus n plus 3 factorial divided by, right, 2, 3, 4 all the way to 11, that is n plus 1, okay, bracket n factorial plus n plus 1 factorial. Okay, notice that this is what we call general term. Every fraction is in this form. All right, so the first fraction is when n is equal to 1, the second fraction is when n is equal to 2, all the way to the last fraction when n is equal to 10. Okay, so this is the general term. So I need to write this fraction into something, right, that is simplified it, so that when you add it together you can find a more simplified version of this rather than like this complicated expression. Okay, so how to simplify this expression? First thing first, okay, let me write down here. Notice that the numerator, I can take n plus 2 factorial as a factor. So the first term, we will just leave it 1. The second term, okay, understand the factorial, n plus 3 factorial, meaning that it's 1 times 2 times 3 all the way until n plus 3 factorial, n plus 3. But I take n plus 2 factorial out, meaning that it will leave me with the last term only. Okay, over n plus 1, nothing changed. Within this bracket, I can take n factorial as a factor. So what's left? Again, it will be just 1 plus similar logic just now. It will just leave me with n plus 1. Okay, let's try to simplify this. Let me write in front. Okay, so n plus 2 factorial do not change. 1 plus n plus 3, that will be n plus 4 divided by n plus 1 factorial n plus 1 multiplied by n factorial, okay, and 1 plus n plus 1, that basically is just n plus 2. I want you to focus on the denominator. Okay? So the numerator do not change. I want you to focus on the denominator. N factorial, meaning 1 times 2 all the way until n, and then multiplied by another n plus 1, and then multiplied by another n plus 2. So this is technically just n plus 2 factorial. Alright, so now both numerator and denominator has n plus 2 factorial. You can cancel it out, so it's just equal to n plus 4. So this complicated expression basically is just equal to n plus 4. So what does that mean? Meaning that when n is equal to 1, this is the fraction, right? When n is equal to 1. And that is equal to 5. This is when n is equal to 2, meaning that this is equal to 6. Okay, all the way until here, that is when n is equal to 10. That means this is just 15. Okay, so let me rewrite all of this out. So hence, the sum is basically is equal to 5 plus 6 plus all the way until 14. Okay, not 15, sorry, I just know, I think I may say 15. It's 14. All right, so 10 terms. All right, this is just sum of consecutive number. 10 term, 10 divided by 2 plus multiplied by the sum of the first and the last term. Okay, so 19 times 10 divided by 2 is 95. Okay, so 95 is the final answer. We have completed this lesson. Thank you for watching this video. I hope you have enjoyed today's lesson. Goodbye, and see you again in another lesson.
If you would like to learn more from these tutorials, please smash that like and subscribe button.